Capacitor banks exceeding a 130% overload as per IC standards require immediate attention. Actions can be divided into immediate, medium-term, and long-term strategies. Firstly, for immediate actions, reduce reactive power input by disconnecting some capacitor banks to lower the total kilovolt-ampere reactive input. Secondly, investigate the cause of the overload by checking for any abnormal loads or system imbalances that are causing excessive reactive power consumption. For medium-term actions, firstly, install additional capacitor banks. Assess the load profile and install extra capacitor banks to meet the reactive power demand without causing overloading. Secondly, upgrade existing capacitor banks, replacing overloaded capacitor banks with units of a higher kilovolt-ampere reactive rating. Thirdly, optimize capacitor placement. Distribute capacitor banks strategically to avoid overloading and improve voltage stability. For long-term actions, firstly, focus on energy efficiency measures. Implement measures to reduce overall reactive power consumption, such as using energy-efficient equipment and improving the power factor. Secondly, explore demand-side management techniques. Consider load shifting or demand response programs to manage peak reactive power consumption. To rectify the situation, firstly, identify the overloaded capacitor banks, determining which capacitor banks are exceeding the 130% overload threshold. Secondly, reduce the load by disconnecting some capacitor banks to bring the total reactive power input within acceptable limits. Thirdly, maximize system efficiency. Implement energy efficiency measures to reduce reactive power consumption throughout the system. Fourthly, install or upgrade capacitor banks, adding or replacing capacitor banks as necessary to meet the reactive power demand without overloading. Fifthly, optimize capacitor placement. Distributing capacitor banks effectively will improve voltage regulation and reduce the risk of overloading. Sixthly, monitor and maintain capacitor banks, establishing a regular inspection and maintenance schedule to ensure proper operation and prevent future overloads. Additional considerations include voltage level and harmonic distortion. Consider the voltage level and harmonic distortion in the system when selecting capacitor banks. Use switched capacitor banks or power factor controllers to automatically adjust reactive power compensation as needed. Engage with a qualified electrical engineer or utility representative for guidance and support. When dealing with overloaded capacitor banks, a systematic approach is essential. This involves not only addressing the immediate problem, but also implementing strategies to prevent future occurrences. The primary goal is to ensure the safe and efficient operation of the electrical system. Understanding the load profile is important. Begin by thoroughly analyzing the load profile of the system. This involves collecting data on the reactive power demand over time, identifying peak periods, and understanding the patterns of consumption. This data will help in determining the appropriate size and placement of capacitor banks. Reactive power compensation is also important. Capacitor banks are used to provide reactive power compensation, which helps to improve the power factor and reduce losses in the electrical system. However, if the capacitor banks are not properly sized or placed, it can become overloaded. Power quality analysis should be considered. Conduct a power quality analysis to identify any harmonic distortion or voltage imbalances that may be contributing to the overload. Harmonics can cause increased current flow in the capacitor banks, leading to overheating and failure. Voltage imbalances can also cause uneven loading of the capacitor banks. Sizing capacitor banks involves determining the appropriate size of the capacitor banks based on the reactive power demand of the system. This should take into account the load profile, power factor requirements, and harmonic distortion levels. Capacitor banks should be sized to provide adequate reactive power compensation without exceeding their rated capacity. Capacitor placement is crucial. Distribute capacitor banks strategically throughout the electrical system to avoid overloading and improve voltage stability. Capacitor banks should be placed close to the loads that consume the most reactive power, such as motors and transformers. This will help to reduce losses in the system and improve voltage regulation. Energy efficiency measures should be a priority. Implement energy efficiency measures to reduce overall reactive power consumption. This can include using energy-efficient equipment, improving power factor correction, and reducing losses in the electrical system. By reducing reactive power consumption, the load in the capacitor banks can be reduced, preventing overloads. Load shifting and demand response is useful. Explore load shifting or demand response programs to manage peak reactive power consumption. Load shifting involves shifting some of the load from peak periods to off-peak periods. Demand response programs incentivize customers to reduce their electricity consumption during peak periods. These measures can help to reduce the load in the capacitor banks and prevent overloads. Monitoring and maintenance is critical. Establish a regular inspection and maintenance schedule to ensure proper operation and prevent future overloads. This should include checking the capacitor banks for signs of overheating, damage, or deterioration. Regular maintenance can help to identify and address potential problems before they lead to overloads. Protective devices are necessary. Ensure that the capacitor banks are protected by appropriate protective devices such as fuses, circuit breakers, and surge arresters. These devices can help to protect the capacitor banks from damage due to overloads, short circuits, and voltage surges. Proper protection is essential for ensuring the safe and reliable operation of the capacitor banks. Voltage and harmonic distortion considerations. When selecting capacitor banks, consider the voltage level and harmonic distortion in the system. Capacitor banks should be rated for the voltage level of the system and should be designed to withstand the effects of harmonic distortion. Using the wrong type of capacitor banks can lead to premature failure and other problems. Switched capacitor banks and power factor controllers are helpful. Consider using switched capacitor banks or power factor controllers to automatically adjust reactive power compensation as needed. These devices can help to maintain a constant power factor and prevent overloads. Switched capacitor banks and power factor controllers can also help to improve voltage regulation and reduce losses in the electrical system. Consulting with experts is important. Engage with a qualified electrical engineer or utility representative for guidance and support. These professionals can help to assess the system, recommend appropriate solutions, and ensure that the capacitor banks are properly installed and maintained. Their expertise can be invaluable in preventing overloads and ensuring the safe and efficient operation of the electrical system. Regular inspections should be performed. Conduct regular inspections of the capacitor banks to identify any potential problems. Look for signs of overheating, damage, or deterioration. Check the connections to ensure that they are tight and secure. Inspect the protective devices to ensure that they are functioning properly. Regular inspections can help to identify and address problems before they lead to overloads. Temperature monitoring is also crucial. Monitor the temperature of the capacitor banks to ensure that they are operating within their rated limits. Overheating can damage the capacitor banks and lead to premature failure. If the capacitor banks are overheating, take steps to reduce the load or improve ventilation. Upgrading equipment might be necessary. Consider upgrading existing equipment to improve energy efficiency and reduce reactive power consumption. This can include replacing old motors with energy-efficient motors, installing variable frequency drives on motors, and using energy-efficient lighting. Upgrading equipment can help to reduce the load in the capacitor banks and prevent overloads. Proper ventilation is also critical. Ensure that the capacitor banks are properly ventilated to prevent overheating. Capacitor banks generate heat during operation, and if they are not properly ventilated, the heat can build up and damage the components. Proper ventilation can help to keep the capacitor banks cool and extend their lifespan. Consider future expansion. When selecting capacitor banks, consider future expansion needs. Choose capacitor banks that can be easily expanded or upgraded to meet future increases in reactive power demand. This will help to avoid the need to replace the capacitor banks in the future. Documenting procedures is helpful. Document all procedures for inspecting, maintaining, and operating the capacitor banks. This will help to ensure that everyone is following the same procedures and that the capacitor banks are being properly cared for. Proper documentation can also help to troubleshoot problems and identify areas for improvement. Training personnel is important. Provide training to personnel on the proper operation and maintenance of capacitor banks. This will help to ensure that they understand the importance of proper care and maintenance and that they are able to identify and address potential problems. Trained personnel can help to prevent overloads and ensure the safe and efficient operation of the electrical system. Reviewing and updating procedures should be continuous. Regularly review and update procedures for inspecting, maintaining, and operating the capacitor banks. This will help to ensure that the procedures are up to date and that they reflect any changes in the system or in industry best practices. Regularly reviewing and updating procedures can help to improve the reliability and efficiency of the electrical system. Remember safety precautions. Always follow proper safety precautions when working with capacitor banks. Capacitor banks can store a significant amount of energy, and they can be dangerous if not handled properly. Always energize the capacitor banks before working on them, and follow all applicable safety regulations. Safety should always be the top priority. Regular system studies should be performed. Conduct regular system studies to assess the performance of the electrical system and identify any potential problems. System studies can help to identify areas where capacitor banks can be optimized or upgraded to improve the efficiency and reliability of the system. System studies can also help to identify potential overloads and other problems before they lead to failures. Analyzing data is also helpful. Collect and analyze data on the performance of the capacitor banks. This can include data on voltage levels, current levels, power factor, and harmonic distortion. Analyzing this data can help to identify trends and potential problems. Data analysis can also help to optimize the performance of the capacitor banks and improve the efficiency of the electrical system. Power factor correction is critical. Ensure that the power factor is properly corrected throughout the electrical system. A low power factor can lead to increased losses, reduced voltage levels, and increased loading on the capacitor banks. Proper power factor correction can help to improve the efficiency and reliability of the electrical system. Voltage regulation is also important. Monitor voltage regulation throughout the electrical system. Poor voltage regulation can lead to equipment malfunctions and reduced performance. Capacitor banks can help to improve voltage regulation by providing reactive power support. Ensuring adequate voltage regulation is essential for the safe and efficient operation of the electrical system. Addressing overloads quickly is necessary. If an overload is detected, take immediate action to reduce the load and prevent damage to the capacitor banks. This may involve disconnecting some of the loads or reducing the amount of reactive power compensation. Addressing overloads quickly can help to prevent equipment failures and ensure the reliability of the electrical system. Proper grounding is crucial. Ensure that the capacitor banks are properly grounded. Proper grounding is essential for protecting personnel from electrical shock and for preventing damage to the equipment. Grounding should be checked regularly to ensure that it is still effective. Surge protection is also necessary. Install surge protection devices to protect the capacitor banks from voltage surges. Voltage surges can damage the capacitor banks and lead to premature failure. Surge protection devices can help to protect the capacitor banks from these damaging surges. Using appropriate fuses is important. Use appropriate fuses to protect the capacitor banks from overcurrents. Fuses should be sized to protect the capacitor banks from damage due to overcurrents, but they should not be so large that they allow the capacitor banks to be overloaded. Using the wrong size fuses can lead to equipment failures. Capacitor duty is another consideration. Ensure that the capacitor banks are designed for capacitor duty. Capacitor duty capacitors are designed to withstand the high inrush currents that occur when capacitors are switched on. Using capacitors that are not designed for capacitor duty can lead to premature failure. Inrush current limiting should be employed. Consider using inrush current limiting devices to reduce the inrush currents that occur when capacitors are switched on. Inrush currents can damage the capacitor banks and other equipment in the electrical system. Inrush current limiting devices can help to reduce these damaging currents. Avoid overcorrecting. Avoid overcorrecting the power factor. Overcorrecting the power factor can lead to voltage instability and other problems. The power factor should be corrected to the point where the losses are minimized, but it should not be overcorrected. Regular maintenance checks are important. Perform regular maintenance checks on the capacitor banks. Maintenance checks should include inspecting the capacitors for signs of damage, checking the connections for tightness, and testing the protective devices to ensure that they are functioning properly. Regular maintenance checks can help to identify and address potential problems before they lead to failures. Proper storage is also a consideration. Store spare capacitor banks in a clean, dry place. Capacitor banks can be damaged by moisture and dirt, so they should be stored in a clean, dry place. Proper storage can help to extend the lifespan of the capacitor banks. Replacing capacitors as needed is necessary. Replace capacitors as needed. Capacitors have a limited lifespan, and they will eventually need to be replaced. Capacitors should be replaced when they show signs of damage or deterioration, or when they reach the end of their expected lifespan. Replacing capacitors as needed can help to prevent equipment failures and ensure the reliability of the electrical system. Following manufacturer recommendations is important. Follow the manufacturer's recommendations for the installation, operation, and maintenance of the capacitor banks. The manufacturer's recommendations are based on their experience and expertise, and they should be followed to ensure the safe and reliable operation of the equipment. Considering environmental factors is a good idea. Consider the environmental factors when selecting capacitor banks. Capacitor banks that are installed in harsh environments may need to be designed to withstand those conditions. Environmental factors can include temperature, humidity, and exposure to corrosive substances. Using high-quality components is recommended. Use high-quality components when constructing or upgrading capacitor banks. High-quality components will be more reliable and will last longer than low-quality components. Using high-quality components can help to reduce the risk of equipment failures. Considering life cycle costs is important. Consider the life cycle costs when selecting capacitor banks. The life cycle costs include the initial cost of the equipment, the cost of installation, the cost of maintenance, and the cost of replacement. Selecting capacitor banks with low life cycle costs can help to save money in the long run. Consulting with multiple vendors is a good idea. Consult with multiple vendors before selecting capacitor banks. Different vendors may offer different products and services, so it is important to compare the offerings before making a decision. Consulting with multiple vendors can help to ensure that the best possible product is selected. Documenting system changes should be performed. Document any changes to the electrical system that may affect the capacitor banks. This will help to ensure that everyone is aware of the changes and that the capacitor banks are properly adjusted. Proper documentation can help to prevent problems and ensure the safe and efficient operation of the electrical system. Finally, the IEC standards are important to be aware of in such situations.